Soil problem in Malaysia is one of the biggest challenges in housing development. One of an example of a soil problem and soil erosion is Highland Tower collapse in 1993. Involved death and losses to the victims' resident occupying the Highland Tower. So there are many grievances and losses. For example, I would like to share that housing loan, every month they have to pay installment to the bank lender. When the Highland Tower collapsed in 1993, based on my information, the resident live there maybe for 15 years. They may be remaining years that they have to settle the loan unpaid. So according to sources, they still have to repay monthly installment even though the housing, the flat, the apartment had been collapsed. So this is one of the grievances and injustices to the resident occupying Highland Tower. This is some of the pictures of Highland Tower. You see, this is total demolition, total collapse. Okay, this picture shows two houses in Taman Gambang, Damai, Kuantan. Early of this year, 2021, if I'm mistaken, in January. Two houses collapsed because of soil movement. Total loss. Nevertheless, there was no injury to the resident there. And this is also another example how soil problem demolish the property and cause losses to the resident. This is also the same event, the same location, but the photo was taken at different angle. So same event also, but different angle was taken. Okay, Tanjung Bunga, Pulau Pinang, landslide happened in 2018, December, caused 2 deaths of the construction worker. Also an example of soil problem and soil erosion at the location of the development project. Apart from them, apart from the problem and the grievances that I've already mentioned just now, there are also issues. For example, in legal matters, I found that Section 108 of the National Land Code 1965 give full power to the state authority, ESCO, Majlis Mesyuarat Negeri, to decide on land matters. In their decision-making process, they are given full power by Section 108 of National Land Code to make a decision without having to be bound by the comments and advice of the planning authority. Maybe that the planning authority provide certain advice and provide certain comment that certain location of land should not be developed for housing development project. Nevertheless, the state authority can proceed with housing development because they has the power under Section 108 to overrule the planning authority decision. Similarly, in the Town and Country Planning Act 1976, the technical agencies, being the professional bodies and department, they can give advice and comment to the local planning authority not to proceed with certain development on certain location. But the local planning authority can overrule the decision and advice of the technical agencies because under the Town and Country Planning Act 1976, there is no provision imposing an obligation on the local planning authority to be bound by the advice of the technical agency. Technical agency here are the professional agency, for example, Jabatan Parit dan Saliran JPS, Jabatan Kerja Raya JKR, Jabatan Mineral and Geoscience, JMGS, etc. Further, Section 95, Clause 2 of the Street Drainage and Building also provide immunity to the local authority. What is immunity here? It means that the local authority is not liable if there is a proven wrongdoing and negligence on their part in improving and approving all the plan and drawings, all the approval. So this is immunity given to under Section 95 Clause 2. This immunity will surely can allow the local authority to escape from any liability. So this is not it's not good in terms of governance. Further, there is no housing insurance imposed on part of the developer to get housing insurance. There is no legal requirement. No legal requirement also imposed on the purchaser. Purchaser may or may not subscribe housing insurance depending on their wishes. Also, there is no updated development plan. Based on my research, development plans consist of structure and local plans, usually prepared by the consultant. The consultant, it is evident that have not prepared rigorously and in detail all the information data to be put into development plan. So the information in the development plan are not updated and cannot meet the contemporary and the current challenges in housing development and land development. Further, I found that there is no updated big data inventory, data analytics for all districts provided by the technical agency, for example, Jabatan Mineral and Geoscience, Jabatan Parit Saliran, JKR, and etc. What is meant by big data is that in each and every district in Malaysia, for example, Jabatan Mineral and Geoscience, they must have all the data information regarding the soil structure, the soil suitability, the soil location, etc. that is good or not good for certain development. So far, there is none. There is none. There is no big data for all districts in Malaysia. This is one of the lacuna, and the planning process is made through ad hoc basis in Malaysia. So, further, there is also evidence that breach of duty of care and negligence on part of an engineer, architect, providing structure plan, earthwork plan, a soil investigation report has not been done, and the building plan also is defective. Site supervisor, clerk of work, contractor workers, resident engineer, and resident architect also evidently they do not do their work to the professional level. As a result, the finishing work done by the developer is not good. This is about quality of workmanship. So tonight, this evening, we will hear the speech by Dato Professor Technologist Dr. Mohd Idrus Masirin on a title, Soil and Construction Failures, Technology and Challenges. Before I proceed, I would read his brief biodata. Dato Idrus started working in 1981 as a technical assistant in JKR, Jabatan Kerja Raya. Mohd Idrus later joined Polytechnic Engkoma as a lecturer. He went to continue his studies doing a bachelor in civil engineering at Hanyang University in Seoul, South Korea, in 1986. In 1995, he graduated with a distinction, doing master in transportation engineering, and was awarded a PhD in geo-highway engineering in the year 2007. As an academician in university, Professor Mohd Idrus was among the pioneering members in UTHM. Since the inception of Pusat Latihan Staff Polytechnic, or PLSP, as a UTM sub-campus in 1993. He has held several senior posts in UTHM and has involved himself in many academic association activities, such as the establishment of Perkasa, Persatuan Staff Academic, kaki tangan akademik, in UTHM. MAC and registering MAC under the Registrar of Society in 2015. Is one of the pioneers to establish the railway program and courses in UTHM with collaborations from from Prasarana, KTMB, SPAN, and several railway-related vendors. Professor Mohd Idrus is an active academician with grants totaling to more than RM3 million, publishing more than 150 papers in journals, proceedings, and books. He also won more than 10 invention and innovation awards locally and internationally. He's won awards in IENA Germany, SIFF Korea, Percipta, ITEX, IRECA, and RISE UTHM. Dr. Mohd Idrus was promoted to a full professor in 2015 and has since still active to participate in academic and non-academic activities in order to contribute to the well-being of students, lecturers, and the community through his knowledge and expertise. Currently, he is a pensyarah sanjung at UTHM, a visiting professor to Universitas Narotama and Universitas Mercu Buana, Indonesia. And he is still imparting his knowledge and experiences with vigor and passion while enjoying his retirement from the Malaysian Civil Service. So without further ado, I would like to call upon Dato Professor Mohd Idrus to deliver his speech on the title given. Thank you. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. All right, thank you very much, Professor Dr. Noor Hilal, as the host and also the what you call the warming up session. Right. I would like to thank the organizer, especially the committee from MAEC for inviting me to give the second talk for Bicara Cendekiawan. And this title is quite interesting anyway, but a lot of the issues being discussed has been discussed by Dr. Noor Hilal, two of the examples, but again, I'm going to just give you an browse to review a few things that is more related to my area, that is more to the engineering aspect of the so-called soil and also construction failure. All right. Let me share with you my slide tonight. I don't know whether you can see. Can you see the slide now?
Okay.
Is the slide moving or not?
Okay, moving.
Okay, good. Right. The title for tonight's talk is on soil and construction failure. But as I mentioned just now, this is going to be the perspective of engineering, not as the perspective of the soil managers or people, property managers and whatnot, but then it's more on the perspective of an engineer. And again, I will just go through with you some important facts about soil, and also later on we'll go into construction case studies. But I'm not going to touch on the Highland Towers, but just a little bit, touching on the aspect of engineering, right? Right. This is me. It was 10 years ago, and actually I studied from the bottom, from getting a diploma and later on going for my PhD, master's, my bachelor, my master's, and later on my PhD. And I was involved in education since 1981, and a brief stint with JKR in 1981. And then later on, I went to Korea and I joined Hyundai Construction over there for a brief stint, 6 months. And then I came back and I joined again the education sector, and in 1995 I joined Pusat Latihan Staff Polytechnic, and which later on became Malaysia. Right. These are some of the information about me, my experiences, my expertise, 40 years of involvement in a lot of things. And I've done also collaboration with few universities all over the world, China, Indonesia, and also I've conducted in also a university in Tokyo, not forgetting some universities in Korea, and also some inventions, and last but not least, some achievement which I consider something which is related to my passion in research and development. Right, as an introduction, what is soil? I think all of us know what is soil, isn't it? So, but again, soil to an engineer is different. Soil, the term of soil to an agriculturist. Yeah? This is what we mean by soil in terms of engineering. So soil are divided into three. It's divided into three, that is air, water, and solid. First, soil is just a soil, isn't it? To the commoners. But then to engineers, soil can be divided into three. One is air, the other one is water and solid. And because of the composition, we should understand that soil will have its weaknesses and also its strength. Okay. And why should we discuss about geotechnics? Because in most cases, people consider it as a difficult subject matter and then not very popular among students, definitely. If you ask anybody who learned about engineering, about civil engineering, they will say that it's very difficult to understand geotechnics. And there's a lot of abstract and also lots of problems involving geotechnics. So this is an example. Landslide. We call it landslide because the soil separates from the main body. So this is something we would not want to see, isn't it? And again, this is also a landslide, a different pattern of landslide. And again, this is another landslide, which is quite dangerous because there are houses and residents at the sides of the hill or the mountain. Right, tonight what I'm going to talk to you is something which is more engineering in terms of what we call soil and also in terms of construction. So again, I'm going to talk about geotechnics and soil engineering, and later on roles of the geotechnical engineers and importance of soil investigation, understanding the soil parameters, and then soil types and characteristics. Later on, we'll go to see what are the types and causes of soil failure and cases to I hope you endure with me because this is very academic in terms of the content, but I'll skip some slides here and there so that it will make you more into the subject matter. So this is geotechnical engineering. The term geotechnical engineering is the branch of engineering concerned with analysis, design, and construction of foundations, slopes, retaining. These are the things that is related to geotechnics, or geotechnical engineering. Foundations, slope, retaining structures, embankments, tunnels, levees, walls, landfills, and other systems that are made of or are supported by rock. So again, if you look at this as the branch of engineering, so it must be very important, isn't it? Especially in construction. Because of that, geotechnical engineering is considered as the first thing to be considered would be looked into when we started our construction. That is the foundation. What are the roles of geotechnical engineers? So geotechnical engineers are responsible for structures, foundation. So as I mentioned, it's about foundation. Work includes assessing data from the field, finding ways to ensure foundations or slopes are stable or not, and designing foundation and overseeing work on the construction. So again, the work of a geotechnical engineer doesn't stop in the lab or doesn't stop in the office, but they goes into they went into the site to see whether things are conducted properly or not. And they often work for consultants. Okay. The engineering field describes soil as the solid material that can be removed without blasting. So soil can be removed without blasting. It is by excavating normally, right? So this is the graphical illustration. We have the clay particles, we have the silt particle, we have the, the voids and whatnot. Also, from time to time, because soil without water will be very compact and it cannot, cannot be flexible enough to sustain the movement. So that's why when we have the earthquake, for example, so the soil moves is because of air and water. Air and water. And air and water is considered as. So comparing geologists to geotechnical engineers. So geologists are the students of the planet. So they study about how the world or the earth are made, and then what are the components of the earth. So the makeup of soil and other materials such as rocks and also, geologists are very keen to look at minerals, isn't it? And geotechnical engineers, they are civil engineers who utilize their knowledge of geology to aid in the design and construction. So depending on the mechanics of the so again, geotechnical engineers or civil engineers, they uses geology knowledge, design and construct structures. So those are the different. So these are a few activities. As you can see, geotechnical engineers, they play with soil very often, and they don't mind if they are dirty. So let's talk about soil and characteristics. So I would like to introduce you to soil tonight. And the definitions, I think we have gone through what is geotechnics, what is geotechnical engineering. And soil mechanics is, I think, similar to geotechnics. I don't want to elaborate on that, but do we conduct soil investigations? And what are the purpose of investigations? So again, when Professor Noor Hilal mentioned about the failure or the disaster that happens to Highland Towers, I think that, most of us will be talking about, well, maybe the foundation is not good enough, or maybe the soil is the main culprit to the disaster. But again, this, in order for us to determine whether which is what and what happens to any disaster, we have to conduct soil investigation. Soil investigation is conducted before the construction and also after the construction, and also again when there's disaster. So soil investigation were conducted according to the purpose of each investigation. And these are the definition that I took from the internet. And when you talk about soil mechanics and geotechnics, these are the mineralogists. Soil mechanics is the understanding the properties and behavior of soil, whereas geotechnics is studying and analyzing the applications of soil and its geological properties for engineering fit for purpose. It means that it's more applied, isn't it? So geotechnical engineering is equivalent to geotechnics by definition, but shows direct impact to engineering. Right. So the soil types, soil is characterized based on its properties and mechanical characteristics. So these are the two things. When you talk about soil in terms of construction, relating it with construction, it is based on properties and mechanical characteristics. So what are the types of soil? We have the clay soil, we have the sandy soil, we have the silty soil, we have peaty soil, chalky soil, and also loamy soil. So again, in the photograph 1, 2, 3, 4, those are an example of the soil that is related to the types of soil. But again, as I mentioned, this soil has its weaknesses and also its. Oh, this is the real. This is an illustration, and this is the real types of soil graph. You can see the color is different, even the way it is, if you touch it, you know that it is sandy clay, sandy soil. This is loamy soil, which is a bit sticky, isn't it? And then which is clay soil. Clay soil is quite unique for anything compared to the other two, because clay soil, when it is soft, it is soft, but then when it's dried, it's really hard. So that is clay soil. So what are the geotechnician contributions? The contribution of geotechnics will be to avoid soil disasters, to avoid loss of lives and properties, reduce continuous settlement and also damages, understand the soil behaviors and properties, last but not least, improve soil for construction. So again, when we talk about soil, most of the time is the number 5, that is improving the soil characteristics, soil properties, construction. And if you don't do it properly, then number 1 will happen. That is soil disaster, soil accidents. And again, sometimes it will involve loss of life, properties, as mentioned by Prof. Hilal just now. Loss of life and properties happened in 1993 when Highland Tower collapsed. Right. So I'll show you some photographs and also information about soil investigation. So these are the soil investigation method that we do. That is by laboratory investigation, and the other one is by investigation. Right. So these are among the importance of soil investigation: to identify the fundamental of soil properties, soil characteristics, engineering fit for purpose, design input as a design input, long-term impact, which many projects, when they conduct the projects, they only conduct short and mid-term, but then long-term impact, sometimes they forgot about it, isn't it? And project feasibility and monitoring, and last but not least, proposal for improvement. So a great proposal for improvements sometimes needs a lot of input from the innovators and inventors. Nowadays, you can see a lot of innovation done to the road construction and also the housing construction. Why? Because they want to reduce costs and they want to reduce also the impact, long-term impact due to the. So understanding soil parameters and properties, there are many soil parameters. We have the basic properties, mechanical and dynamic properties, and also its characteristics. And among the soil parameters and also properties that is being taken into consideration by a lot of engineers are cohesion, which actually will have an impact on the bearing capacity, on the strength, and then liquidity, plasticity, permeability, homogeneity, shear, compressibility, void ratio, and sensitivity. So again, these are the properties that were considered by geotechnical engineers. So it's not easy for actually geotechnical engineers to come out to a conclusion that a certain site or a certain type of soil is considered as suitable or not. Right. Why is soil mechanics important for civil engineers? As I mentioned just now, the soil mechanics is the most important thing before a construction project is conducted. So it is the foundation. It lays the foundation for any construction project. Yeah. But again, when we talk about civil engineering in general, it is about the requirement for civilization to build the civilization in the world. It started in early 18th centuries, 19th centuries, where in the UK they started to have the civil engineer as part of the Army Corps, and from there they expanded, and civil engineers being established in many agencies and many departments to help in the development of even any development projects. Okay, right. So these are the properties, properties of subgrade soil. For civil engineers, I think you are familiar with this. So these are some of the information, and it's not easy. You have to get a lot of for civil engineers. You have to acquire a lot of important parameters, important information about soil, right? Right. Talking about laboratory versus field investigation, which is better? Because civil engineers, they are not, all keen to do laboratory work, and they are all are not keen doing field work. But then they must know at least a little bit about laboratory work, and later on they know how to supervise a field, and conduct field investigation. So both has their advantages and disadvantages, and laboratory works are an ideal condition, but then the field works are really means that laboratory works are actually a situation, a condition that is considered as very ideal, whereas in field works, it normally has to anticipate a lot of challenges. For example, the different water table, the moisture content will change because of the heat or because of the rain. So these are the things. The weather uncertainties is another challenge for geotechnical engineers or civil as a whole. Laboratory tests are easy to control and predict, but field tests are full with uncertainty and surprises. And laboratory tests can be repeated, but then field tests, you cannot repeat it, isn't it? Because you are on a full-scale test, full-scale construct. You don't have the chance to repeat it in anything because it will cost millions of ringgit Malaysia. Field tests are real-time, but engineers must always use their wisdom to overcome challenges. So again, until now, even though there are a lot of engineers or people who came out with a lot of conclusion or assumption about the failure of Highland Towers. But again, we must come back to reality that Highland Towers is an experiment or experience that we don't want to repeat, because what happens can be assumptions, and it involves a lot of money and a lot of lives actually. Sadly, about there are people who died unexpectedly because again, what actually happens that should be revealed to the public, but until now we haven't heard the reality behind the tower disaster. So again, looking at this, I think these are some of the equipments and so the test procedures being conducted on site, the sampling, and some laboratory investigation. You can see we also conducted laboratory investigation, laboratory tests. Nowadays, you can see there's a lot of very sophisticated equipments linked to the computer, and which is real time sometimes. We can monitor it from afar using the internet. So again, these are the application of technology in geotechnical engineering, in soil engineering. Okay. But again, everybody must know that actually for geotechnical engineers, we have our own, what you call, reference in doing things. So we have the Norwegian Geotechnical Institute, Oslo. This is where most of the standards are being formulated and being shared globally. Right. Talking about field investigation, so these are a few things that need to be conducted. Investigation is planning, management skills, and also we have to also conduct appropriate measures and contingencies if the plans are not able to be conducted, because as I mentioned, there's a lot of challenges conducting field investigation. Okay? So these are the examples of samples that were from the field. And we also conduct soil boring. Yeah. So instrumentations, I think nowadays there's a lot of instrumentation with the high-tech ground linked to the computers. As I mentioned, we can conduct remote monitoring when we do, geotechnical monitoring process. This is the loading, dynamic cone penetration, some testing, as I mentioned to you earlier. And each investigation, type of investigation will require different training. And as mentioned here, fieldwork needs strength and determinations, skill to handle fieldworks, operators. Laboratory works are typically easily organized and less mobility because it is in the lab, isn't it? Skill are acquired by understanding and practicing the SOPs for operators. Operation of fieldwork equipment must be conducted after training, and trained supervisor must accompany researchers. Again, trained supervisors normally will be trained engineers, isn't it? And they must accompany researchers equipment because they wanted to avoid any what you call accident during work. So you can see here, this is the worker is conducting some testing. This is the Macintosh block, and students are being trained. Right, we'll go to the types and causes of failures. Soil failures on site. What are the types of soil failures? Well, they can be divided into two. One is the man-made. It's not the man-made, man-made, and also some are natural disasters. So the landslides that can be considered as natural disaster, but again, at the same time, it is due to the man-made works, because when we construct roads on hillside or mountainside, and if there is landslide, it's because we construct the road, isn't it? But sometimes natural, just like what happens in many of our mountains or hills, naturally when the soil give way and also the trees are not able to sustain, so there will be landslide. So that is considered as natural disaster. Settlements due to time and workmanship. Settlements due to time is called consolidation in engineering terms. So if it's long term, then it's called consolidation. Or workmanship. Sometimes settlement is because of workmanship that is not good enough in any vibrations, any an impact of loading and whatnot. Earthquakes, that is considered as natural disasters, and floods. So floods again, there are two types, isn't it? One is man-made, the other one is natural disaster. Natural disaster is because there's no maintenance, or there's heavy sudden heavy rainfall, and because of that there were floods. But then nowadays floods that happen around us are because of man-made, because of the activities, man activities, because we construct a lot of new structures, new buildings, and because of that, we actually created floods, especially in cities. Because in cities, if you don't actually provide good drainage or enough drainage for the surface runoff or water running on the surface, and then you are going to have, definitely you will have floods. And sometimes we term it as the flash floods or banjir kilat. Why? Because it comes when there's heavy rain or unusual heavy rains. And this, surprisingly, is not considered as disaster. Flash flood is not considered disaster by the Malaysian government through NADMA, because they say that it is not something which happens naturally. So but again, that has been debated yesterday, I think yesterday or 2 days ago, in the parliament, and the deputy minister has agreed that they will look into this terminology. Once again, floods, whatever it is, flash flood or normal flood, it has an impact on two things. One, on the properties, damage on the properties. And the other one is on the loss of life. Yeah? So loss of life is something which have to take seriously. Okay. Right. This is an example of failure where you can see the slope is failing, and we don't have alternative but to repair it, because this is both side of the plus highway. So if we don't do anything to it, definitely this will have an impact on the road users. And what are our alternatives? Well, I can propose a few alternatives, but then it depends on how much budget we have, isn't it? So we can do this. This is using stones or rocks. We can make a rock embankment there, and then we can actually solve the problem of the slope failure. Or we can do this combination of the cement rock embankment with the what you call the grass covered embankment. So again, this is considered as cheaper. But again, you have a lot of money, you have the budget to go higher than this, and the two proposal that I've given to you, you can do this. This actually is being conducted at places where it is very critical. It's very, and if you go to the creek to Kelantan, highway, you can see a lot of this. It's being constructed and being monitored nowadays, so that there will this again. There's no guarantee if you use rock bolting or soil nailing, it will not collapse. But again, with good monitoring, inshallah, this will sustain the life, design life of the right. Cases of construction failures due to soil. Understanding about soil, and then understanding the type of soil that we have, and understanding what are the possible solution, that we can opt. I think now we are ready to see what are the cases of. Right. These are some lists of soil failures in Malaysia. So this list is taken according to, in random, because I know that within the 1 hour duration, I'm not able to discuss all this. The famous Highland Tower building, 1993, that has been mentioned by Prof. Noor Hilal. And the Gua Tempurung mudslide. This is something is quite interesting in Perak. Well, in 2000, it happens in 2004. And there are, fortunately, there are not many, vehicles or lives being lost during the mudslide. But again, this is another a national disaster, which is unforeseen because of the sudden, change of weather. So at that time, we were talking about El Nino and whatnot, And the Taman Muda flood, which happens every year. If Gua Tempurung happens in 2004 or Highland Tower in 1990, what Taman Muda flood in Shah Alam happens every year. So can we consider this as a disaster? Well, it's up to you to say whether it's a disaster or not. Because Taman Muda flood is not directly related with soil failure, but then because of the sedimentation, soil sedimentation in the river, so that created the possible flood every year. And you know that every year we will be experiencing the monsoon season. So because of this, Taman Muda flood will always revisit people who are around that area. The Cameron Highlands and Kuala Kubu Baru landslide in 2004. Since 2004 and until 2021, there are still cases where there are soil failures at the hillside, at the mountainside, and this is something which is I don't think this is unforeseen, but then this is something which should be considered by the JKR or the local authorities, so that it will not reoccur. But then it reoccurs every year, every time there's monsoon season, which I think, in my humble opinion, something which is of this issue should be considered as very serious by the I've presented in 2007 a paper on Cameron Highlands landslide. And I presented a method of how to monitor landslide. But again, it happens until recently in October 21. there's report about landslides in Cameron Island. So why this happened? Well, the answer is with JKR, also the local authorities. The Cebu pit construction failures. This is not so famous. If Highland Tower is a famous, soil failure case study, but Cebu pit construction failure is not so famous. And it's happening now, until now, since the establishment of Cebu as a township in 1862. Until now, there's a lot of problem with pit, Cebu pit, where people, when they construct their houses, they construct a lot of around Cebu township. Still, there are failures here. Why this happens? Well, maybe it's because we don't have enough budget to construct a good road, or maybe we don't have enough budget to construct. Why? Because constructing buildings on pit is very, very costly. But again, because Cebu town is situated on pit, they don't have any thought. And when I visited the University College of Technology in Cebu, I told them that actually you are very fortunate because your university is in a very big open lab. We call it open lab. But Cebu is an open lab for pit. So if you construct anything on pit and you want to know what happens, you can go to Cebu and with your own eyes, you will see there's a lot of construction failures, and there's a lot of solution, being put up by JKR and local authority, so that they can still survive and sustain the building infrastructure. So this is something which is, and the Simpang or the Senggarang Rengit coastal road failure. Well, actually, talking about this is also not very famous, isn't it? Something which is more localized to me. We conducted a survey in 2019, and during the survey, it was actually the road newly constructed, but after a few months, we found that there are a lot of cracks, a lot of failures here and there, all along the Senggarang Rengit coastal road. So why this happens? After spending millions of ringgit Malaysia, why this happen? Is it because we don't have good and enough detailed site investigation, or is it because the construction technology, the way that we construct the road, is not good enough to fail? So again, these are the things that we have to look into when we talk about soil and also. Right, this is some photograph on the reported by Bernama quite recently. The cracks on Federal Route 185 involving Jalan Simpang Kulai and Blue Valley in Cameron Islands. And this is another one recently, also 24 September 2021. Extent of damage that can be seen afar along section 44. So again, you can see here that actually these are slope failures, because of soil. And if you just imagine, if you are actually here, traveling on this road here, where you can see the excavators there, you will be actually really, frightened to actually use a road which is Right. Just to go, I'll take a few more minutes to discuss about this Cebu pit construction failure. Research conducted in 2015. Talking about Cebu pit construction failure, I think what we found out is that buildings were constructed on pit soil, high water table, and Cebu is situated near to Sungai Rajang. If any of you who are from Sarawak, you know where is Sungai Rajang, isn't it? It's very near, just adjacent, or I think in the middle, is actually part of Cebu. Yeah, and ongoing problems are the settlement and buildings after 20 years. Initially, if it's two-story building, it remain only one story because another story has gone into the soil. Roads after 20 years, each year were resurfaced and some were reconstructed. Just imagine 1 kilometer of road cost more than 1.2 million, and now it is more costlier. The one that I'm involved with the Lawas, Lawas construction road construction network, which actually is part of the Enborneo. Now it costs more than 3 million per kilometer. So this is Cebu town at Rajang River. You see, as I mentioned just now, it's part of the township. And the population is 180K, 180,000. It is 130 square kilometer. See, you can see here, Sungai Rajang. It's just part of the township. More than 60% is PT soil, and established by, they say it is by James Cook in 1862. It means that officially it is being opened by James Cook in 1862. And the density, population density is 1,300 people per kilometer. So it's quite dense. Yes, for town like Cebu. Right. And this is Cebu in the old days. You can see even if you look at the roofing, it is made of metal. This is how they construct the houses, and they have wooden houses around. And until now, if you go to Cebu, you can see the wooden houses around and still. And this is Cebu at night, quite nice. I've been there many times. I think more than 10 times I went to Cebu. And this is actually city. Okay. This is again Cebu. You can see this Sungai Rajang is quite vast and big river. I don't know how many crocodiles are there, but then definitely there are. And as you can see, the sides, the river side is almost on par with the water level at the river, isn't it? And these are some problems that they face. They face a lot of problems because when it rains, the water table are high, and then the roads will get eroded, and there will be cracks here and there. They have to do this, either they resurface it totally. Don't have money, they will do this, resurfacing partially, which is not so good for road users, because when you come across patches, this will not be very good. Right. There are also reports about the effect of man-made projects like Bakun and also Murum Dam, where at the end of the day, these projects, which is targeted to supply water and also supply electricity to Sarawak and also to towns in Sarawak, will have an effect on the well-being of the cities, on the township, or the people who are at the downstream. Yeah, you can see here, Cebu is one of the downstream township, and with these dams, there will be, I think, a lot of problems, because if you know about peat actually loves water. So it lives in water and it breathes in water. And without water, then peat will actually be destroyed. And if it's destroyed, just imagine, peat consists of more than 80% of water. Yeah. And if this 80% is taken away, just imagine you have only 20%. See? So what will happen? Then there will be, the oil will actually settle, and then there will be a sort of a sudden decrease in oil volume. So I can't imagine what happened to the downstream township or this downstream settlement if this happens. So that's why they say that this is a cascading failure. So because of the, and you can see this is part of the places or residents in school. You can see initially, yeah, the one that is being in a circle. Initially, this was actually horizontal with the road, but then because the road settles faster than the entrance to the house, so the bridge has become like this. So it is it has a differential, what happens is differential settlement. Okay. Also over here you can see all the cracks, all the holes because of settlement. And this is the walkway. And again here you can see the disaster that happens. And when I went there, the last was in 2008. The house has remained only the top, the first story, the second story, the ground story is gone already at that time. And at this you can see that water is not going away, even though you have what you call a drainage system, but the water doesn't go. It's just, and because of that, then it started to erode and create a problem to the. You can see here this one, that photograph here. This is what happened to the houses over there. But again, that's why people, they still live in the houses, because they bought the houses 20 years ago, 30 years ago, and then because of this, they finished paying, but then they have these problems, but they don't have the money to pay. This costs major repair, isn't it? And this is the situation when you actually want to do any construction. When you actually clear the soil around the Cebu area, you will see that they are covered with almost peaty soil, all soft soil. So how can we construct houses and also work on very soft soil? So this is a challenge that a geotechnical engineer and also civil engineers have to face in. Right. Another challenge that a civil construction civil engineer has to face is constructing a bridge. So there was a case reported by Ong on a bridge failure. The construction is a 13.5 kilometer single carriageway linking the existing Ikan Bridge Post University site in Cebu, Sarawak. So again, the soft soil of maximum 30 meter thick, the soft soil, and that soft soil is peat, which were found below the 5 meter thick peat layer. So is peaty soil under a thick 5 meter peat layer. They were treated with prefabricated vertical drain to reduce post-construction settlement so that design requirements were met. The site investigation and soils characterization test, it was successfully using hydraulically placed sandfill to replace the underlying fibrous peat. So again, as I mentioned just now, the effort to actually improve the soil bearing capacity is not to reduce water, the volume of water inside the pit, but rather is to enhance and improve soil bearing capacity. That is what is being conducted by the engineer over there. Settlement plates was installed to monitor the settlement of the sand layer PVD system. It was shown that the rate of settlement increased markedly when PVD was installed. Field instrumentation results was checked observational method to measure settlements. Okay, so again, how did they do it? It is like this is what I've taken from the paper that we actually produced and refer to the paper on this issue, where actually there's a lot of challenges. But again, as I mentioned over here, when it rains, the soil is very, very soft. Even though we put the PVD there, but still it is a method that we use. But then whether it is successful or not, it depends on this, because the soil is, and also the weather, just like the weather, is very unpredictable, especially in Cebu. Right. Talking about the Senggarang and Rengit coastal road failure, this is something which is also considered as very, very challenging. The Senggarang-Rengit coastal road is an alternate route to JB from north via BP. So again, via Batu Pahat. This is considered as part of the coastal route from the north to the south, and the road was resurfaced every time it is damaged. So it has been actually resurfaced every year, and until now we haven't actually come up with a good solution. Design is for single way, and is a federal road. During the observation in 2019 and 2018, we noticed that there are cracks at the near side of the road, and accidents due to road damages and uneven surface actually happens from time to time, because especially when it is rainy and during the at night. So because people that do not see what is ahead when they are driving, especially the motorcyclists. The route is congested with villages nearby, so there's a lot of population around the route, from Batu Pahat to even up to Badon, and the failure is due to, this is what we found, failure is due to traffic loadings resulting in settlement. So coastal soil settlement created the road failure. So that is what happened to be the Senggarang Rengit Coastal Road. So this is the Senggarang, and also this is one of the photographs that we took to actually show that the cracks is getting bigger and bigger. So because of these potholes or cracks, it will actually have an impact on motorcyclists. And this is an example of road defect at Senggarang Rengit roads at the roadside. And even though the authority has done the road patching projects and whatnot, but still there are also, failure. And why this happened? Well, there's a lot of, aspect or reason that this happens. So challenges of construction, right? So construction is needed due to development of settlements, isn't it? So we need to actually have better houses, better roads, better infrastructure. That's why we conduct construction. And soil cannot be changed. Soil cannot be changed, but it can be improved, rehabilitated, or remediated. This is what you cannot change the soil. You cannot, even though you try to change, but how much can you change? So for example, like Cebu, 5 meters of pit soil, and you excavate 5 meters of pit soil and then transfer it somewhere else, and then import 5 meters of soil, good soil. I don't think that is practical. New methods, technology can improve or can be proposed, but it does not necessarily. You must understand that, and engineers knows that. Engineer knows that any new methods of technology which has not been used can be proposed, but it may not necessarily. And last but not least, engineers need the technology to solve problems, but most importantly, so this is for engineers. I hope engineers understood that the technology can assist you to solve problems, but most importantly, engineers need wisdom and cooperation from leaders. You have to have that wisdom to actually decide what is best, what is the best solution for a system. And most importantly is how much budget do you have at the end. So be a wise engineer when you do this. As a closing remark, soil investigation is important. Laboratory test also is important because it can simulate or identify properties of soil. Disaster happens because of human, can be avoided. So, but again, in big construction or big projects, when disaster happens, we shouldn't blame anybody, but again, we should find the probable cause and try to avoid it individually. Disaster due to nature is unavoidable, definitely. So that's why when we talk about disasters such as the landslide or even the Highland Towers, we should look into what are the situation of weather at that time, also whether it is because of the weather or it's because both weather and also the design of the building or the design of the drainage system, infrastructure. So those are some probable causes of the disaster, in construction. New technology can assist in improvement. As I mentioned just now, technology can assist us to improve and also to prevent. And again, nowadays we are very fortunate because we have the GPS and whatnot. So it can also assist us in monitoring the existing construction. But again, are we utilizing it? So if you construct any structures or any infrastructure which is considered at a location which is critical, then we should have this, the monitoring gadgets, yeah, so that we will be having the so-called benefit to be, alarmed or to be acknowledged before any disaster happens. Yeah. Right. So recapping, I think geotechnical engineering from the definition that I've mentioned just now, and with geotechnical engineering, we can keep the and the world definitely. So soil is something which is unpredictable and very difficult to sustain. And you can see here that if erosion happens, this will happen to us. We do not want this to happen to us, and we try to avoid by creating and understanding soil more than ever. And we don't want this also to happen. But again, how to avoid this from happening? We have to actually conduct a lot of innovations and ventures and also use new technologies to monitor this. And some geotechnical successes, I think this is very common to us. You know about the, pyramids, you know about the ancient Roman roads, you know about the Great Wall of China. Talking about failures, yes, we fail a lot, but then we must understand we also have successes. Even though soil is very unpredictable, but we'll never know what will be in the future. But again, we must also celebrate our successes, soil engineering, and hopefully in the future we will have more successful stories. If you look into in China, they have done a lot of new construction wonders in China, and also I think in Malaysia we also have some engineering success stories projects done by Malaysia. All right. And last but not least, just think about this. These are the few things that normally I share with my students, my colleagues. Think outside the box, thinking inside the box, and without the box, which is what is your opinion in thinking outside the box or thinking inside the box or thinking? Nowadays we are now moving towards the box, moving towards the thinking without a box, yeah, because the challenges are too great, and if we only think what is outside the box and what inside the box, then we are going nowhere and we won't be competitive enough. So with that, I thank you very much for the opportunity to present about the title of soil and also construction failure, and hopefully this has give you some idea, some insight of what is soil and why construction fails when it is property. And with that, I thank you very much, and I'll pass back to Prof. Ilham.
Thank you, Dato, for your elaborative speech just now on the soil and construction failures. So in legal aspect, it is about liability. When soil problem occurs, when soil settlement landslide occurs, there would be losses to life, losses to property and belongings. People suffer, the victim suffer, the victim aggrieved by the soil problem. So in law, what is the remedial action should be done in order to rectify the problem so that the victims can go to the can be restored to the original position before the occasion of the soil problem. That is the business of law actually. So like the problem occurred at Highland Tower, the issue is the compensation until now is not enough to cover the losses of the victims. And I heard that the Ministry of Housing and Local Government is finding ways to prepare some compensation to the victims in the project. So they call it in law is irreparable damage. Irreparable damage. Even though the engineers or the developers might be held liable, but bottom line, do they have enough money to pay the compensation or not? Firstly. Secondly, whether they have insurance coverage or not. Thirdly, whether the insurance coverage and the monetary provision that they have can cover the losses suffered by the victims. Highland Tower illustrates a problem where the developer, the insurance coverage is not enough to cover the losses and grievances of the victim to restore their position to the original position before the event, before the damage occurred. That is the challenge, the challenge in legal aspect. Even until now, we can see that in the Housing Development Act also, there is no imposition on the developer to subscribe housing insurance. The liability of the developer only covers within the defect liability period 2 years. Within 2 years after the delivery of vacant possession, the developer would only be liable within 2 years. If there's a soil erosion, soil settlement, damage occurred to the building, the developer only will be liable within 2 years. If the soil erosion or soil settlement that caused damage to the belonging and building occurred after 2 years, after beyond 2 years, the developer will not be liable. So that is another dilemma in law. They call it is this legal challenge. Legal challenge that until now the jurists, legal jurists, legal academics as well as lawyers and judges are they are discussing on this matter. It's still not conclusive. It's not easy subject. So thank you very much, Dato, for your descriptive and detailed understanding, imparting of your knowledge and experiences to us that we can understand in the perspective of civil engineering in regard to soil aspect. Before I conclude the session, I would like to open this session to any question from the audience. Any question? So if there's no question, I have one question, Dato. So usually in the soil problem, in housing development project, soil settlement, soil problem, landslide in housing development project, based on your experience and knowledge, whether the causes occurred during the preparation of the plan by the civil engineers, during the preparation of the design of the building by the architect, or during the construction by the developer under the site supervisors, management, under the clerk of work management, under the work of the contractor labor. What's your opinion? Normally, the causes, the causes. Which one is the most dominant area that then that's where soil settlement and soil problem and soil erosion originated from.
Right. Thank you very much for the question. I think that is a good question. But again, talking about soil failure or a failure of construction due to soil, I think one of the issue that we have to understand is uh, architects, they come out with a design of the structure, or they come out with the architectural perspective. They don't actually do investigation. They don't actually design based on the technical, the requirements or the technical findings. But the engineers are the people actually who design and who checks the design through calculations, and also using the data that they have. They do the analysis, and then later on they come out with the conclusion of their design. At the design stage, I don't see there's any problem. Any problem, because it is being checked by several engineers and several parties, the consultants, even the contractors. They have several discussion and meetings. But the most likely and probably the problem that occurs is during the construction. As I mentioned just now, doing site investigation, doing site work, there's a lot of challenges, and there's a lot of things that we have to change from time to time. Sometimes what you call the assumption and also the decision by the engineers on site will have an impact on the long-term sustainability of the project. So it is likely that during the site work, that will determine whether your structure or your infrastructure or your drainage system will actually sustain the design life. If the design life is for 100 years, then what happens during the construction by the engineers, by the contractors, by the developers will determine the ability to actually complete the design life. But again, mind you that actually it is something which is not totally on the part of the contractors or developers' fault. As I mentioned just now, sometimes it is because of the uncertainty due to the weather changes, the storm, the storm requirement, or the storm, weather changes, storm water from in 50 years ago, 30 years ago, with what we have now will be different, isn't it? The drainage system will be different. Even the road, for example, if you have road, you construct a road which should sustain 20 years, but then because of the rigorous development around the road that you constructed, which increase the number of vehicles, then the road might damage faster than it should be. Maybe the design life of 20 years will be shortened to 10 years, maybe, because of the sudden development, rigorous development around the road. Similarly, for a river, the same thing. A river is impacted by and affected by the surface runoff which goes into the river. If there are a lot of surface runoff around because of development, then the river might be flooded, and at the end of the day, overflowed, and the rest of the area will be flooded. So again, construction, construction procedure, construction, detail by the contractors, by the developers who are involved in any construction project, they must be actually, be more particular in executing their work. I'm not saying totally it is their fault, but again, if something happens, normally it will go back to the consultants, contractors, and also developers. So That's why when you ask me, if you ask me, what happens to the people in the Highlight Tower, and some of them gone mad, because they gone mad because if they go to the side, they will say that my house is over there, it's on top. They cannot do anything. The house is on top, is it? So bought hundreds and thousands of apartment, cost 100,000 apartment. The whole tower has actually collapsed, so they don't have the house anymore. And the bank, the financial agency, they are not paying them anything, even not a single cent, which actually create more psychological on them. So that's why my advice is, if you want to buy an apartment, make sure that you buy an apartment which is at a strategic place, which will not have this what we call this disastrous ending. If you buy an apartment which is on a place, a flat land, then the possibility of apartment collapse is almost zero, isn't it? But then if the apartment is on the hillside, then it is very critical for you to consider whether, well, maybe you like the views, but then you must remember that there will be consequences, there will be possibility that a disaster to the apartment will happen in the future. So that is my opinion, and I think as a lawmaker, Prof. Hilal, the lawmaker should actually look into this matter, appropriately and seriously, so that not only we can solve the problems of the developer and also the people who are involved in the construction structure, but then also the clients, to the people who actually bought the apartment. There should be a clause protecting the rights. They should be paid whatever sum but then there's no question asked. Just like in the Western country, if you are involved in a dispute, normally the client will be given the benefit of the doubt. Yeah, well, you have paid your due, you paid and you own the apartment, but then suddenly because the tower collapsed, so you lost everything. I think that is not fair. So the insurance company should not consider that as an excuse not to pay, but rather the insurance company, they are taking the money of their client every year annually, paying the client the amount that they should be given. I believe if this is not being taken into consideration by the lawmakers, like Professor Hilal, who is a professor in law, isn't it, about properties and whatnot. But then in the future, you will be experiencing difficulty. Developers will be experiencing difficulty in convincing people to buy apartments, because better for them to buy landed property, which if anything happens, you still have the soil and then you can reconstruct your house, isn't it? But then if you lost the apartment just because the collapse of the tower, then you can't do anything because your house is in the air. How can you reconstruct your house? So that is something we should be taken into consideration when coming out with solution, how to help the residences who bought apartments in the future. Okay, Prof. Thank you.
Okay, thank you for the answer, Dato. I think
Welcome.
this is the, I mean, we can conclude now if there's no question. So on behalf of the MAVC, I would like to thanks Dato for having agreed to deliver your speech and talk to this evening. Thank you very much. And
Pleasure.
the audience, thank you for patiently wait until the end of the program. Please do fill up the attendance form your certificate, the e-certificate will be delivered to you through your email, respective emails. So thank you very much. Until we meet again in the next and other programs. Inshallah, with this, I would end the session with Tasbih Kifarah and Surah Wal Asr.
Surah.
So before we leave the session, could you all, the audience, turn on your video? We want to take pictures. Please, please turn on your video. Okay, I will take photo.
Yeah, yeah.
Okay, please
You
turn
see
on
my
your video.
photograph. You can
I
see my
think
video kan?
I think these are all my students. Criminal law and CPC. Can
Thank
you
you very
showcase
much for attending. All of
criminal
you.
law and criminal procedure law? Okay, one smile, a big smile. 1, 2, 3. Wait, I want to save first.
Thank you, Dr. Felix, for joining us tonight.
Dato, before we end the session, could you share your PowerPoint or not? Your PowerPoint slide.
It's breaking. Pardon?
Could you share
Okay,
your
I'll share with
PowerPoint
you.
slide?
And then you can share with the audience later.
Okay, Assalamualaikum and very good night. Thank you.
All right, good night. Thank you.
Ya, Assalamualaikum.
Waalaikumsalam. Terima kasih.
Sama-sama.